It's the adventure of our science of physics that is a perpetual attempt to recognize that the different aspects of nature are really different aspects of the same thing. That all the phenomena that you see, the great variety of different things, can all be explained, perhaps, as different aspects of some underlying business or some underlying laws or some underlying simplicity. Any other situation in quantum mechanics can always be explained afterwards by saying, you remember the case of the experiment with the two holes? Suppose that we have some source of bullets, then a long distance from here we have another plate, and it has two holes in it. That's the famous two-hole business. We have another screen here, we can put a detector. So what we measure then is the probability of arrival to find out whether it's through hole 1 or hole 2, or maybe they go around through both holes or they split up. If we go to analyze this curve N1, 2, we can interpret it as a sum of two curves, which can be represented as an A1 plus an A2, which we call a probability amplitude. To arrive from hole 1 plus the probability amplitude to arrive from hole 2, and you add the two together to get the total probability amplitude to arrive and square it.
And this is my desk lamp. If it's not bright enough, you can switch it on. It shall be placed close to the writing surface, at the center of the desk. This is my cup of tea, which shall be placed on my left-hand side, here, and it can be tucked away, so I can use the mouse and write with my right hand, and reach the tea with my left hand. This way, the cup, the monitor, and the hard drive, objects with fixed locations, are aligned, and things that need to move are in this area. On the other side of the desk, I can place the book that I am reading, and since the lamp is placed in the center, it can easily be turned to the left or to the right. And there's enough room to place the book and turn it into different positions. And when finished, the book can be stored away in the corner. The pavement is to be placed like this, crossing the entire width of the path, so that the blind man will for sure run into it. In order to make way for the manhole cover, the path has to make a turn. As a result of this, part of this is removed.
This proposition that I'm talking about is more general. It's not just for two holes. And read something like this, that the probability of any event in an ideal experiment is the square of something, which I call A here, is called the probability amplitude. And when an event can occur in several alternative ways, probability amplitude, this A number, is the sum of the A's for each of the various alternatives. And finally, if an experiment is performed which is capable of determining which alternative is taken, the probability of the event is the sum of the probabilities for each alternative. That is, you lose the interference. So that the uncertainty principle is used as a general principle to guess ahead at many of the characteristics of unknown objects. They are limited in their character.
The government is to pump around £200 million into the building of a new garden city in Kent.
Politicians like the idea of creating leafy, pioneer towns like this from scratch, but they've grown less keen on saying where they should be built.
For the first time in 100 years, going to build a garden city.
We're seeing demand going through the roof, 390,000 new households formed last year and 114,000 houses built, and we simply aren't building enough houses.
Well, it will be a proper garden city.
It's not enough and he should do more.
How do we actually going to build at scale to provide homes for the future?
What is the scale of your house building ambition?
That will mean 120,000 new homes across the country.
There have been plans for homes here since 2003.
Land Securities have planning permission to build 6,000 homes here, and it's where the government want to see what they call a new garden city. But hold on, shouldn't we be able to see some houses over there?
To be fair to Land Securities, they have started to build out the first 150 homes.
What this ultimately means is a family simply cannot afford to buy a house, and I'm not, as a Chancellor, prepared to let that rest.
This is Penzhanger area. This is the existing housing area. 700 new houses are to be added into the area. The first option would be to remove the existing aerodrome and place the 700 houses there. Or we can get rid of the greenfield, keep the aerodrome. Or can we not keep both the greenfield and the aerodrome and superposition the 700 new houses onto the existing housing area? Each plot of land will now have to accommodate an average of 2.14 houses, 2.14 families, 2.14 sets of possible activities and events at each moment of time. So how can a plot of land be multiple houses at the same time? Before that, let's look at just one of the existing houses. This is 27 Mendelssohn Penzhanger. But this is not just 27 Mendelssohn Penzhanger. It is also 25, 24, Mendelssohn, 23, or 22, 247, 246, 245, Kentland Street, Toronto, 655, 654, 653, West Virginia Avenue, Morgantown, 156, 155, 150, Glasgow Avenue, Melbourne. But let's start with 27 Mendelssohn Penzhanger. Just like every other house, it is designed up to standard. The logic of a standard house considers your home as composed of boxes of rooms, and your activity divided into categories. And in each room, a prescribed set of standard movements and standard activities are to take place. And what happens if I am not the standard person, and my habits and my needs are not the standard ones?
This is actually two end tables stacked on top of each other because I never found something that fit this space. We don't actually ever use this room. We do not eat dinner in here, so it's kind of a useless dining room.
Your house considers you as superpositioned in all possible activities at all times. But instead of a superpositioned user, can we have a superpositioned house instead? So that a house can exist partly in multiple possible states, as multiple possible houses at the same time.
As time went on, there was a growing confusion how the things really behave. They do not behave just like particles. They do not behave just like waves. They behave in their own inimitable way, which technically could be called the quantum mechanical way.
This house will constantly oscillate between different states, such as position, size, location, and functions.
Is that all these particles are made of something else called quark, which comes in three varieties, A-type, B-type, or C-type quark, okay? And depending on the different proportions, how many A's, B's, and C's, and how they're moving around each other, if we count how many states we would get from putting three objects together, it could be made in so many ways, 27 different ways. And then when we allow for their motion around each other, we find the higher energy states analogous to the way that we ought to get. And even semi-quantitatively, there seems to be a relation between the states, the rates at which one turns into another